Hello guys, welcome to this video session of modeling an energy storage system using Simulink. So let me tell you about the energy storage system and why it is required. So one of the critical tasks in EV or HEV system or hybrid electric vehicle system is energy storage, and specifically this electrical energy storage. So previously, lead acid battery have been used in traditional automobiles for very long time to aid with starting the vehicle, running various devices such as windshield wiper, automated window, or many other auxiliary devices. So there are not quite sufficient for this energy storage in EV and HEVs. So some of the better batteries that have emerged as good candidates for electric vehicle applications are nickel metal hydride batteries, lithium ion batteries. So today in this session, we will see how we can model one lithium ion batteries using Simulink library. So I think you can see my screen. Here I have designed a lithium ion battery. So we will see how we can design it from scratch. So let's create a new window. So by clicking this new option, we can create it, or there is another option. So for specifically different Simscape modeling, we can use one command, that is ssc underscore new. If I type that, you can see there by default one one window got created. So it's specifically for Simscape library resources. You can see here. So let's start the modeling. So first, what we will do, we will first start with making the thermal subsystem for that battery, and later on we can see how we can create the battery and integrate that thermal system with the battery. We will see that. So to make the thermal storage thermal subsystem, let's start with a constant block. So you can search here constant, or you can search here, right, PS constant, or that is nothing but the a particular constant block from Simscape library or physical system library. So once I open that, you can see here you just uh, give the parameter as 25 degrees centigrade. So here I have defined 25, and from here I can specify the unit. So for now, there is no need to specify the unit. I can just give like this one. Or what we can do, instead of this Simscape constant block, we can use one simple Simulink constant block as well. So there is no difference. So as I open this, and let me set the parameter as 25 as the uh, ambient temperature for the battery will be 25 degrees centigrade. So that's why I have set it here 25 degrees centigrade. Okay. Now let's take temperature source. So for taking that, what we can do, we can just click here in our library browser, or as well as we can search here as well. So for more clearance, let's search here. So we will search temperature source, sorry. So once I search for it, you can see here this control temperature source is there. So I will copy this and I will just fetch here this source option, this source port. I will connect it with this. So as you can see, this is in color. So that means it is from Simscape library. You can see it here as well. So to convert this Simulink signal to physical signal, or for compatible with this Simscape library, we need to use this PS Simulink to PS converter. So I will simply take this, I will connect it here, and this output port I will connect with the source port of the controlled temperature source, this thing. Okay. Now what I will do, so here if you open this, you can see here this AC is nothing but the source, and A is the positive temperature difference cause the temperature at the port B. So A is the nothing but the reference. So what we will do, we will just search here for temperature reference. Okay, let's search for simple reference. Okay, search here. You can see here thermal reference. So this thermal reference we will take. It was not temperature reference, it was thermal reference. So that's why we are not able to find it here. So thermal reference we have taken, and we will connect it with the A port. So that it can make a difference and send it to the output port B. Okay. So I have connected it. Now here I will connect one convective heat transfer block so that the heat can be convected and be transferred as well. So what I will do, I will search here for convective heat transfer. So you can see here, this one is the convective heat transfer block. I'll simply copy it, and this B port. So the temperature is nothing, it is going from A to B, right? So what I will do, I will just make it reverse, because we will see, because this is nothing but the ambient temperature. So it's not the source. Source is the battery. So I need to reverse the direction. So I will just reverse it using Control R, and I have connected this B port with B port. Now I need one temperature sensor here. So I will search it for here. So temperature sensor. Okay, I have spell it correctly. Okay, if I search, okay, let's search here. Temperature sensor. You can see here this temperature sensor. Maybe I have done something wrong. Okay, so I have get it, and I will just rotate it a bit. This A port, I will connect it with this A port. This T is nothing but the output port from where we will see the temperature, and this B port I will connect it with this port. So this is connected. Now what I need to do, I need to create one connection port. So you can see here connection port. So I have taken this connection port. I will connect it here. Just let me rotate a bit so that it can look fine. Okay. So now I have connected it. And here this temperature is a physical signal. So I need to convert it to in term of Simulink signal. So I need this just reverse of this Simulink PS converter. I need PS Simulink converter. So you can see here, it is available here. So I will copy it from here. Also, you can do one thing. You can search for it and you can take it. So let me just connect it here. Okay, I have connected it, and need to connect one output port here as well. So I will search for output port. So you can see here I got output. I'll just connect it here, out one. Just let me name it. Name it as temperature. So let me just, okay, so I have named it. Okay, let me just show the block names as well here, as well here as well. Also for this as well. Okay, also for this. Just let me name this block. Okay, let me just name this block. So you can see here the name is still constant. So let me name as ambient temperature. So it is the environmental temperature. So I will name it as excuse me. So I will name it as ambient temperature. So I have connected it. Now what we need to do, we need to set some parameters. So for this convective heat transfer block, let me set some parameters. So the area, it is by default 1 into 10 to the power minus 4 meter square. Let me just change it to 0.1 meter square. Okay. And as well as this convective heat transfer coefficient, let me change it as 0.1. The unit is watt per meter square Kelvin. So it's same. Okay, just let me just, it is auto applied, so it will be by default saved. So I have done that. Let me put it into a subsystem. So what I will do, I will simply right click and I will select the whole thing, and here you can see create subsystem option. I will just click it here. So by default it will be put it into a subsystem, right? So I put it into subsystem. Now let me just rotate it so that in future it will be helpful. So from this port we will see the temperature, we will observe the temperature. Let me rotate it, and this port is nothing but to connect with our battery, right? So what we will do, we will now search for a battery block. So just double click here in the blank space, or you can just click it here as well. Just let me search here. So here I will search battery. So from the battery, you will get several type of batteries. From here, just search, just take this battery electrical specialized system, this battery. Okay, so just it's loading. So you got the battery, right? Now, what you need to do, you just right click it and you can see here, there should be an option for block choice. Block parameters. Okay, what we can do, we can just take another block as well. So just delete this for now. Just let me search here for battery. You can also search it here. So you can see several batteries are there. Just take this battery from Simscape library only. So we have taken the battery. Just let me organize the whole thing. Now just right click on it and basic characteristics paste mask. Here you can see block parameters. Let's click here. Okay. Yeah, just let me click here. Okay, here you can see Simscape option. So just select this and now this check on this modeling option, this option, and from here just select this instrumented this show thermal port option, this option. Once you click this, so your battery will be capable to log the temperature data as well. So just change it. So simply just right click on it, go in this Simscape option, go for this modeling option and just select instrumented show thermal photo. This one. Just I have selected this. Now, what we need to do, I need to set some parameters for this battery. So just I will connect it after some time. Let's select the parameters first. So first here, what I will do, I will change the nominal voltage as 300 volt. This internal resistance I will set to 1 into 10 to the power minus 3 ohm. This battery charge capacity I will change it to finite. It's not infinite, it's a finite element, right? Then the cell capacity ampere hour rating I will change it to 100 ampere hour. You can just change the parameters as per your choice. You are free to do that. You will get a different result then. So it doesn't matter. So it's up to you. Now this voltage V1 when charge is 1 a means ampere hour, so I will just change it to 270 volt. Then this I will set to 50. So self discharge should be disabled. Measurement temperature I will just change it to 25 degrees centigrade. Okay, here you can see there will be, so degree C I will set it. Now select the parameters for the dynamics. So here you just select 2 time constant dynamics. Once we select this, we will get several options. Just keep this default values. Okay, what is by default is given, just keep that. Then we will set for, so in fade just disable it because it will come into picture battery aging and those things, capacity fading, those things. Just ignore this thing. Then I will also this calendar aging as well. Now we'll come to this temperature dependence, this option. Here just you need to change the nominal voltage value as 300. Then this internal resistance at second measurement temperature. So if you just, you can see here second measurement temperature, we will set to 1.001 into e to the power minus 3. Okay, ohm. This voltage V1 at second measurement temperature, this one we will change it to 270 volt. Then this first polarization resistance we can keep it as 0.05 by default, whatever it's given. This thing also you can keep it by default value. Then second polarization we can keep, this also we can keep. Okay, the second measurement temperature just change it to 0 because it doesn't matter to us. Degree you can change to degree centigrade. Now this thermal port, just change the value for the thermal port, thermal mass, just change it to 89400 joule per Kelvin. So it's the tested value for a battery. Based on that battery, we are just trying to model that battery. That's why we are changing these values. Now in this variable option, what we can do, we can just check for this charge, and if we just go here, you just change it to 80 ampere hour, and the temperature we can just go for this, and we can, you guys know already what is the temperature, so it's 25 degrees centigrade. So we will just keep it to 25 degrees centigrade. Okay, now all our parameters has been setted. It is auto applied, so just close it. Now we need to connect these things with our model. So for that, this H port we will connect with our connection port. So let me delete this thing. H port is the, let's connect here. Now what we will do, I need to connect a reference. So we'll search for reference. So it's an electrical reference. So we'll search for this thing. So this negative minus port, we will just connect it with the electrical reference block. Now we will search for one current sensor to measure the current value that is coming. So search for current sensor. So current sensor we have already, okay, this one we will take, we will connect the positive port with the positive port, and negative port we will connect it after some time. For now, just let me copy this here, keep it here. Okay. Okay. Now we have to take one voltage sensor to measure the voltage value as well. So we'll search for voltage sensor. So from the similar library, foundation library underscore this, we will take this block. So every time this voltage sensor is need to be connected in parallel, and current sensor or the ammeter is connected, need to be connected in series. So that's why you have connected like this. Now just connect this negative port with the negative port, connected this. So there is one concern about every Simscape models. So every Simscape models must need to be connected with at least one solver configuration block. So that's why we need to use the solver configuration block. By default, it is given once we created one Simscape model file. It is by default given. So we need to connect it here. Anywhere you can connect it. Doesn't matter. You can connect it here as well. So I've connected it now. Now we need to observe the values, observe the voltage. So what we can do, we can give some from and use some from and go to blocks to connect these things to observe the values. So just do one thing. Let's do one thing. So we'll search it for one go to block. So yeah, find go to block to connect it. Okay. So as you know, this is Simscape blocks and this is Simulink block. So it's that's why it's not connected. So we need to convert these things. So we need this physical signal to Simulink converter this block. So what we will do, we will just let copy this thing. Okay. Let me copy this. Let me connect it here. Just Control R for rotate this. Rotate this. I've connected this port and I will connect it here as well. So still now it has not been connected. Okay. Now we'll just give the name for this block. So it's nothing but the voltage, right? So we will give it name as voltage. We'll just rotate it. Similarly, this one we also need. Just let me copy this thing. I'll copy and copy this thing. Just Control R to rotate this thing. Okay. Now we will just connect it here. So you can see here it is connected. So it's not voltage, it is current. So we will name it as current. This current. So previously you have observed here we have by default already connected one PS to Simulink converter. Once we connected it with this temperature output port. So here further we don't need to connect another PS to Simulink converter. What we can do, we can simply connect one go to block here. So just change the name and just name it as temperature. So we have named it temperature. Just Control R to rotate this. We'll just connect it. So you can see it's got connected here. So we need one scope to observe the behaviors. So what we will do, we'll just take this scope as well only, or you can search for one scope as well. And we need to take the from blocks from this go to block, right? So from block, how we can take, we can just uh, take it and just copy from this arrow option. We can just copy this, just control R to rotate. Let me change the temperature, name as temperature. From the temperature go to block, I have copied this. So let me name it as temperature. Then similarly, this arrow is coming. So I will just left click and drag it. So it will be created. Just let me name it as current. Current. Similarly, okay, current is already exist. What you can do, you can take this name, or you can do one thing. You can just, okay, just let me do one thing. Let me delete these blocks. So I'll come to this after some time. Let me first, I just missed out this thing. So this is the output port of the battery. Whatever charge we will get, it will come from this port. So you know, this is a Simscape block. So I need to connect one PS to Simulink converter to get this charge and convert this into SOC. So to convert this into SOC, what we will do, we need one gain factor. So just search for the gain block. So it's a Simulink block, gain block. So that's why we have just copied this physical Simulink converter to convert into Simulink signal. And we will just connect this block with it and just change the gain factor. By default, it is set to 1. So to convert the charge into SOC, the gain factor will be 1 divided by, in bracket, 100 into 3600. Right. This is the gain factor. So it's by default estimating as 2.778 into 10 to the power minus 6. I will just click apply and OK. So our gain has been setted. Now let's connect go to block here as well. So I will just copy this. I will connect it. I will name it as, okay, just change the name, just cross the name. What we will do, hide the block name. Okay, what we will do is just change the parameter as well. This, and the tag I will name it as temperature. Okay. Just let me just maximize this so that the whole name can come into the screen, fitted into the screen. This voltage, let me just change the tag from A. So by default, it has been created as A. Just let me change the tag. So it's again voltage. Just change it. Okay. So you can see it is showing voltage. Similarly, this one I need to change into current. So I will just search for, I will just type it here, current. Now what we can do, we can just copy this ports. So now you will be able to see the name. So there is no need to double work for this thing. SOC we got, current we got, voltage we need. So for voltage, we can just click on that blue arrow and we can just drag this. Let me just rotate this thing. So to rotate this, I will use shortcut of Control R. Now I will connect it here. Let me just change the size. Also, one I got missed, that is temperature. Okay, so temperature need to copy and just let me just rotate this. Okay, so I have rotated this, I have connected this port. Just let me organize the whole thing. Okay, so that it can looks good. Now let me just check the current and okay. Similarly, this voltage one as well. The temperature as well. Okay, I have created this. So all the blocks, all the parameters I have connected, except the important one, that is the current source for the battery. So we need to charge or discharge the battery. So for that, we need to give one current source. So for this case, we will just charge this battery and we will observe the parameters, how the SOC is increasing and how the voltage is increasing and those things. So for that, what we need to do here, just search for controlled current source. Once I type CO, you can see here controlled voltage source, controlled current source, everything came. So I will search for this controlled current source. I will take this. I will just connect these ports. So as you can see the arrow, the current will flow from positive to negative, right? This like this. So that I have done, and I will use one constant block to specify my current. So you know that this is a Simscape block and we need one PS to Simulink converter to convert this signal from Simulink perspective to Simscape perspective, right? So, okay, so I've just take the wrong block. So we don't need PS to Simulink, we need Simulink to PS, right? So let's search for Simulink to PS because this is Simulink signal and this is PS signal. So we need Simulink to PS converter. So just copy this. I'll just rotate it and I will connect it here. Connect this as well. Control R to rotate this thing. Now we can simply specify here the value. So batteries. So if we check the battery parameters, so battery ampere hour is 50 ampere hour, right? So okay, so it is rated as 100 amps hour. So let's charge it with let's charge it with 0.5 C rate. So 0.5 C rate will be 20 amps, right? So let's change the current parameter value as 20 so that it can be compatible with 20 amps. And let me also show the block names here, here, and for this one as well. Okay, this dot. Okay, so I have shown the blocks. Now if I just run it for, let's say I will run it for, let's say 500 seconds. So if I run it, you can see it is compiling. Okay, first of all, I have not saved this block, so I should save it. It's a good practice to save. So to save, I will just click in the save button, and in the save as, I just name it as lithium ion. Okay, and I will, so by default the extension is .slx for any Simulink model. So just save it. So you can see lithium.ion got saved. Let me click here one save button. Okay, so it got saved. Let me run it again. So it's compiled and it got run. Now, if I just open the scope, I will be able to see this. Okay. So here I have connected four signals, but I have not specified different layout for this. So that's why this is all messed up. So let me just click on this view option and click this layout button so that this can be fitted in five different. Okay. Now it created. Let me just click this. Okay. So you can okay. Let me also just turn on the legend. Is for to open the legend here first I need to specify the signal name. So it is SOC. This one is for current. This one is for voltage. And this one is for temperature. Let me specify this. So once I specify it, now if I open this and just go to this view option and just click on the enable this legend option, you can see here. Okay. Okay, still it is showing like this. No issue. So you can understand this thing. Okay. So the first one is nothing but the SOC. Okay. So it's increased from 80% to 83% once we charge our battery with 20 amps of current for 500 seconds. It increased for 3%. Okay. From 80 to 83. If I increase the time, maybe it will charge for more time and the SOC will be increased further. The current is constant, so it's 20. So as the battery is charging, that's why it is showing minus 20. And when the battery will discharge, it will show plus 20. So that's why it is showing 20 for whole 500 seconds minus 20 as it is charging. Then this one is nothing but our voltage. So voltage, it starts from 292 volt and it increased for another 1.5 volt and its final value reached to 293.5 volt. Okay. And at last, this thing is nothing but our temperature. So our temperature increased from 298.15 Kelvin to 298.155 Kelvin. Okay. So let me increase the time a bit. So let me increase the time for 5,000 seconds. So we will see more changes in the observations. Okay. So I have run it for 5,000 seconds. So it got run. And now let me save it. Once it is showing star, that means it's not saved. So now it got saved. So if I just open this and let me just do this. Okay. Now you can see, okay, I have just overcharged. Let me do one thing. I can change. Okay. Okay, just let me initial target value. Let me just change it to 50 amps hour. Okay. That is 50% charge already. If I run it now, if I open the scope, okay, now you can see the battery is already previously it was 50% charge and the SOC increased for 30% more and the final, okay, not 30% more, it's almost 78%. Okay, so 28% more have been charged. Okay, more has been charged. You can see here for once we charge it for 5,000 seconds with 20 amps of current. You can see for whole the time the current is constant is minus 20 for charging. Okay, and this one is for voltage. So voltage increased from 270 volt to 291 volt. Okay, almost 291 volt. Okay, similarly this is the temperature. So temperature has not that much of difference has been created. So it started with 298.15 Kelvin and it increased for more 0.10 Kelvin, and the final temperature after 5,000 seconds, it increased to 298.25 Kelvin. Okay. So this is the parameters. So we can change the parameters here to see more different things to get the variation in the results. We can do that. So that's how, simply using this battery block from Simscape library, we can design a lithium ion battery, and we can charge it with different charging current or discharging current. Okay, so here we have already seen, once we charge it with a constant current of 20 amps, let's just take a random signal. So for now I'm using drive cycle source. So it's basically drive cycle source, but we can use the value for charging as well. So I'm just using it here. So as I want to vary the current, so that's why I'm using this drive cycle source. You can use one signal builder block as well and create your own signal, or also you can do one thing. Okay, it is not connecting. Let me just connect it. Okay, so also you can do one thing. You can just uh, log your current data and you can charge it here. Let me run it. I think it will not. It will throw some error. Let me run. It run for 5,000 seconds, as the till the drive cycle is for only 2474 seconds. Okay. Okay, still it got run. Just let me. Okay, here it is throwing some unit mismatch. Yeah, that's why it is throwing this error. Let's just not use this. So you can create your own signal with signal builder block as well. Or what we can do, we can use some step. Okay, so let's step time is 1 second. Sample time, let's change it to, let's say 5,000. Okay, or 500, 5,000. Initial value is 0. Final value is, let's say 20 amps. Now, if I just connect it and if I run it, you can see it will run. Maybe here you will see some changes. Okay. Okay. Just use a constant block instead these steps and other blocks. Or you can just create your own current data to observe this thing. Constant block you can use. That is the best option for now. Just let me change this for 20 amps. Time is already set at, I think, yeah, it's already set to 50,000, 5,000. So similarly, we have seen this previously. This is the behavior we will get. So thanks for watching this video. So if you came across any doubt, please ask me.